So we're given a function here, a of t, and a of t represents the value of an investment after t years. And a of 0, or a sub 0, is the initial investment. In part A, we are asked to find what the investment will be worth, or what the initial investment of $3,000 will be worth after 2 years. So a of 2 years is equal to 3,000 times e to the power of 0.065 times 2, which is 3,000 times e to the power of 0.13. Punch that in your calculator and we get an investment value of $3,416.49. We want to find the value of the investment after 5 years in part 2. So that will be 3,000 e raised to the power of 0.065 times 5, which is 3,000 times e to the power of 0.325, and that gives us an investment value of $4,152.09. And in part 3, we want to find what the investment value will be after 25 years. So do the same, plug it into the formula. And we get 3,000 times e to the power of 1.95. And as you can imagine, this will balloon to a pretty big value. And that value, according to my calculator, is $21,086.06. Let's take a look at part B. How long will it take for this investment to double in value? So what we're looking for is a value of t. Okay. And for what value of t, or after how many years would this double in value? Or will it become $6,000, double of 3,000? Okay. So really, this is all about solving an exponential equation. Okay. So first I'm going to divide both sides by 3,000. Our unknown is in the exponent, so I'm going to take the natural log of both sides. So take the ln of both sides. And according to the ln or log property, the exponent will come down here to get 0.065t. And ln of v, we know it to be equal to 1. Divide both sides by 0.065. Punch that in your calculator, and we double our money in 10.66 years. Let's do part C. So in part C, at what rate is the investment growing at the time when its value has doubled? Well, we know that its value doubles after 10.66 years. Okay. But we want to know the rate of change of our investment exactly 10.66 years later. So here what we need is we need a functional expression for the derivative, okay, or the instantaneous rate of change of our investment. Okay. And the derivative of a of t will be 3,000 times e to the power of 0.065t. And using the chain rule, the derivative of 0.065t, which is simply 0.065. Simplify this expression, and we get 195 times e to the power of 0.065t. So this functional expression allows us to basically compute the rate at which our investment is growing at different times of t. Okay. In our question, in particular here, we want to find how fast our investment is growing at time 10.66 years. So I'm going to plug in 10.66 into my derivative. And that gives us 195 times e to the power of 0.065 multiplied by 10.66. Plug that in your calculator and we get a rate of change of $389.90 per year.